So we've been discussing various economic features in Alaska, particularly oil and gas development, and the pros and cons of developing possible oil and gas resources in ANWR, the Arctic National Wildlife Refuge, and how there has been huge national debate over that, and things like the Exxon Valdez oil spill and the pipeline, etc. But today we're going to get a little more science-based, and we are going to discuss. I would like you guys to understand how your local communities are affected by these contaminants that may not happen on your property or possibly even miles away from your property, but can still affect the water that you are drinking in your own homes, or that your friends are drinking, or that is in the pools or streams or rivers that you are fishing out of or playing in. So, here's a general overview of the water cycle, or the hydrologic cycle. Hydro meaning water, ology meaning the study of, so that is why it says the hydrologic cycle as well as the water cycle. They both mean the same thing. So here's a basic overview. You've got an area of accumulation, and water tends to travel from uphill to downhill. And so points of accumulation are going to be streams, rivers, lakes, the ocean, areas where they are lower down in elevation than the areas around them. And the water will always travel downhill. And so we see water evaporating off of this lake or ocean of accumulation, and evaporating is turning from a liquid into a gas. They then condense up in the clouds, so going from a gas back into a solid form, and the clouds form, eventually holding so much water that it can't contain it any longer, and it comes out as precipitation or rain, and that liquid water falls then on the ground. Other ways that water gets up into the air is transpiration, which is how plants give off of water to the environment, plants being a very important source of water, and oxygen as well, which we will discuss when we get to our plant unit. And so then we've got all this water falling on these tops of these mountains and hills, and eventually it will need to make its way downhill again, back to the points of accumulation. So it does that either as surface runoff on the surface, or it will go underground and become part of the groundwater system, and that is also called subsurface runoff. But both of them will travel in the same way, meaning from high ground to low ground based on gravity. So here is an example of a groundwater table underground. Not all groundwater tables are going to be in the same place, but typically what happens is near the surface you have areas that are permeable, which means that they have spaces that the water can move through. Water is liquid, the soil being solid. The spaces between the soil is big enough for liquid to filter through or infiltrate, and the water will make its way slowly through the soil. And if there is any contamination in that soil, the water can pick that contamination up and carry it along with it, depending on how different pollutants attach to water. And eventually it will make its way to an aquifer, which is an underground containing area of water. And usually that happens because there is a very hard rocky area, bedrock type rock that holds the water in place. The water cannot trickle through that rock, and it holds that water in place. So in this area, there's a huge groundwater table because of probably lots of bedrock underneath it somewhere. But then there's this area that's called an aquiclude, which you do not need to know, but it is another area that is in a random area in the permeable soil that is an impermeable layer, a hard layer that holds the water in a very localized spot because it is so solid that the water cannot trickle through in that area. So that is how groundwater gets under the ground, collects in certain areas together, and travels downhill. So here we see it traveling downhill just like surface runoff travels downhill. so does groundwater, but it just travels through the ground. Again, like I said, if you have anything buried that is contaminating, the water can travel through that area and pick up those contaminants and carry them to this. In this example, it is a stream that it is being carried to as an accumulation point. And that confining unit there is kind of one of those very solid areas of bedrock that the water cannot travel through. So it ends up traveling downhill, underground, until it hits this stream. In this slide, I just want you guys to start understanding how land is used in our cities. And this is taken from Seattle. Anchorage didn't have as good of a pie chart to show you, but we have very similar land use. Even though Seattle is much bigger than us, percentage-wise, we use our city in similar manners. So single family, that almost 50%, 49% of that pie chart is being used up by houses that have one family in them. That parks, open spaces, and cemeteries is 14%. That's the next biggest use of land. Anchorage also is lucky enough to have a lot of park spaces and green belts. And then we have 8% of the land being used by multifamily units. That means apartment buildings and condos and places where you have more than one family on the property together. And then you get into the kind of certainly people can pollute their property very well, or their sewage can leak, or their fuel systems can leak, but then some of the major polluters are the major institutions and public facilities and utilities and industrial areas and commercial mixed-use areas, which all of those include your factories in the industrial area. Your public facilities would be hospitals and schools and police stations, things like that. Commercial mixed-use areas are lots of different shops. All of these areas are going to be different sources of different types of contamination. You've got metal workers and auto body shops. All these folks are going to have pollutants of different kinds that react with the water differently if they get out into the water system. So another thing that we are going to need to understand is that there's two main sources when we refer to water pollution. There's point source pollution, where you can narrow it down to a specific location where that pollution is coming from. Here's a great picture of point source pollution. We can see that yucky yellow water coming directly out of that pipe. We can find out where that pipe is connected to, and we know exactly where that pollution is coming from. However, non-point source pollution is a huge problem because we have so many parking lots and roads and areas that have lots of different types of things that can leak and spill and mix together all in one area and get washed around, and that is called non-point source pollution. Parking lots and roads being a huge source of non-point source pollution, with leaky cars and all sorts of other things getting spilled on them and mixing together and eventually finding their way into the water system or into the ground and then into the groundwater system. So here are other sources of rural contamination. We have rural areas up in the valley of Alaska, Wasilla and Palmer, and you may not think that those will affect you, but if you go visit those areas, or whether if you live downhill from those areas, then it is possible that any contamination there could affect the water that is getting to you. So in this photo we see a water table. It's being confined above a very solid layer of rock, but it's below the surface of the ground, and we've got all sorts of possible contamination. You've got fuel storage areas, you've got sewage system from the house, you've got manure storage from the animal, the livestock, you've got fertilizers, and you've got just all sorts of different possible points of source of contamination. And this is just in a rural area. This is in a less populated area. So this slide, all you need to understand is that water is that green band right there. Water is often what we are talking about as mixing with these contaminants and carrying them. Now, many contaminants will dissolve directly into water, like fertilizers and pesticides, what we use to kill bugs and to help plants grow. Those actually mix in with water. It can mix it right into the water and contaminate the water itself, making it very hard to clean up and to separate those contaminants from the water. Other contaminants called DNAPLs and LNAPLs are the DNAPL stands for dense non-aqueous phase liquids, and LNAPL stands for light non-aqueous phase liquids. All you have to know for that is the non-aqueous part means that it does not mix into the water. And the dense part means that it is more dense than water. The light part means that it is lighter than water. So, all of those things on top of the water there, the vegetable oil, the rubbing alcohol, the lamp oil, lots of things from gasoline and jet fuel are LNAPLs, and they are lighter than water and they will sit on top of the water. So wherever the water goes, it will carry those LNAPLs with it on top. And so if anything jumps into the water or is mixing with that water, it will get those contaminants all over it, which is what we saw with the Exxon Valdez oil spill and any other oil spill, because the oil sits on top of the water. DNAPLs, you can see like dish soap, and these are not contaminants, but chlorinated solvents are one of the biggest sources of DNAPLs that are denser than water. They sink below the water, and things from metal cleaning and degreasing and dry cleaning clothes and leather tanning and painting, those things are all contain DNAPL chemicals that will sink below the water and be carried along underneath the regular water system, but will contaminate that water because it eventually will mix in and it will be carried along on the bottom, contaminating the bottom of any water source. So, sediment, it seems funny, but dirt can contaminate our water as well. You get too much dirt in the water, that clouds it up, and you can't get enough oxygen in there for plants and animals to be able to thrive and to live. And one of the main sources of sediment in the water is erosion. And erosion comes when you have any area that you're farming and cutting down a lot of plants and trees, or logging and cutting lots of trees. Anywhere where you're cutting down lots of plants, those plants have root systems. The root systems actually help to hold that sediment into place. As soon as you start getting rid of root systems, you start and killing trees, then you have dead root systems that won't hold on to, or no root systems, and erosion starts to get lots of dirt into the water, which can really cause problems quickly as far as killing off any living things. So here's one more slide of a kind of more populated area that has industry. It has farming and agricultural pesticides. It has gasoline tanks from your gas stations. You've got animal waste. You've got people who will flush their drugs into the water supply, or your sewage waste runoff. A lot of those things, this shows most of those contaminants in this diagram getting into the pipes. Mostly, a lot of those things will leak into the ground, as we saw, and trickle through the soil into the underground water table there that we see. Some examples, though, recently in Flint, Michigan, can actually contaminate the water in the pipe itself. If the pipe is made out of lead, for example, which is what happened in Flint, that lead will start flaking off into the water, and that is poisonous. And if you don't replace all of those lead pipes, then you will have poisonous water, which is what Flint is dealing with right now. So, one more summary of a nice glass of water there. It could be nice and clean, but you've got all this stuff going on. You've got natural gas wells, you've got storage tanks for fuel, you've got a person's private well, probably a sewage system as well. All of these things can make their way underground and into the groundwater. And that groundwater, if you, like I do, I drink water out of a private well. So if anything contaminates my groundwater, I am in trouble. And so we get it tested regularly. Thankfully, we live near the mountains, and there's not many points of industry or pollution between us and the mountains, so not many things to leak into the water that will head towards us. But if you live in a flatter area and you have car shops or dry cleaning or any type of storage tanks, people's own fuel systems, if you have neighbors and you are downstream, you probably don't want to drink out of a well, because they will somehow, there could get pollution in the water that you don't know about. So your ticket out the door today at home and into the door tomorrow, it will be on your Google Classroom, which you're used to accessing, assignment number 4. I will see you in the morning, and we will discuss any questions that you have, and we will go over all of this again if need be. So thank you for your attention, and have a good night.